Welcome once again to my YouTube channel, and I want to respond to a question in number 6, exercise 1 star question number 8. The resistance R ohms of some wire is directly proportional to its length. And we have understood in the previous example that direct proportionality resistance is directly proportional to the length. And this being the symbol of proportionality, we need now to introduce the constant of proportionality and have it R is equals to KL. And then R is a variable resistance, L is a variable that is talking about length, and K is the constant of proportionality. So we are given some details. A piece of wire 600 millimeters long has a resistance of 2.1 ohms. A piece of wire which has a resistance of 2.1, that is 2.1 is equals to K 600 millimeters. So to get the value of K, we must divide both sides by 600 millimeters, so that we have K is, we have to divide by 600 both sides. So 2.1 divided by 600, we get, this is 3.5 times 10 raised to the power minus 3, where this decimal point will have to go 3 steps to the left, making K to be 0.0035, and that is our value of K. So we go now to part A of the question. Find the resistance of 1.5 meter length of wire. Remember, the length that we were working with here is millimeters, and now we have a length of 1.5 meters. So we'll have to convert these meters into millimeters. So 1.5 meters, to make them centimeters, starting first of all is through multiplication by 100, because we have 100 centimeters in 1 meter. At the same time, to make the millimeters, we have to multiply by 10, because we have 10 millimeters in 1 centimeter. So this makes the whole thing 1.5 times 1000, which is 1500 millimeters. And now we have our length in millimeters. So the question is, find the resistance of 1.5 meters length of a wire. So R is equals to K, which is 0.0035 multiplied by 1500, and that's where we are now. So times 1500, and we find this is, the resistance is 5.25 ohms. This is resistance, ohms. That is part A of the question. Part B of the question, find the formula connecting R and the resistance. Now, find the formula connecting the R, which is the resistance, and L, which is the length. And it goes without saying, we just come back here, because we know R is a variable. So the formula is R is equals to, K is a constant, 0.0035, L, because L is another variable, meaning the length of the wire keeps changing, the resistance also keeps changing, but K is a constant, and that is the formula connecting R and L. And finally, part C of the question, Thomas needs to make 7.7 ohms resistor. How many meters of wire does he need? In this case, in part C, the resistance is already given, 7.7. We need now the L, but the constants K never changes, 35 L. And to make L the subject of the formula, we must divide both sides by 0.0035, 0.0035. and we find that L is equals to now 7.7 divided by 0.0035, and we find this is now 2200 millimeters because we have been working with millimeters. But the question is, how many meters? How many meters does he need? So to make these meters, we will have to divide by 1000 because in 1 meter we have 1000 millimeters. So 2200 divided by 1000, we get 2.2 meters. And that is the answer to question part C. Again, subscribe to my channel, follow and share, and also comment, and let us work together. Thank you.